All right, welcome back for example 4. Let's go ahead and look at it. What it says is that we're going to be proving triangles are congruent. So we're given this figure. We have some given information. It says BC is parallel to AD. I wonder why they would tell us that. And then it also says that BC, line segment BC, is congruent to line segment AD. What we need to prove is that triangle ABD, this one here, is congruent to CDB, this triangle on top here. So let's go ahead and do that. Okay, the first bit, they give us this parallel piece. So why would they give us this parallel piece? Well, if you look, we have two parallel lines, and then we have this line right here. If we extend these lines, right, extend this, and extend this, and extend this, and then this right here becomes, we extend this, this becomes our transversal. So if I were to draw these lines over here, our transversal is right there where this is B, this is D. Okay, do you guys see that? So with this, what is this when these two lines are parallel? Remember when they have the parallel lines with the transversal, so just so you can see, this here is the part that is right here, and this part here is the part that is right here. Sometimes it's hard when you have these other lines there, so okay. So know that when we have these parallel lines, that opens the door to the alternate interior angles theorem, the alternate exterior angles theorem, the corresponding angles theorem, and the same side interior angles theorem. So what do we have here? We have the alternate interior angles. We know that these two angles right here and right here are congruent by the alternate interior angles theorem. So we know that we have that. Okay, so we know that. So we have this side, we have this side, we have this angle. What else do you guys see in this picture? Well, I see that in this these two triangles, they share this side right here. So that means that it's the same. So BD is congruent to BD. So what do we have? We have a side, we have an angle, and we have a side, and that angle is in between those two sides. So let's see if we have that. We have side, angle, side here, and we have side, angle, side here. So therefore, we can show that these two triangles are congruent because they are some sassy triangles because of side, angle, side. So let's go ahead and write that down. So we're going to start here. This should be a line segment. So line segment BC is parallel to line segment AD. That is given information. Because of that given information, we can say that those two angles are congruent. So I'm going to say angle ADB is congruent to angle CBD. And that is because of the alternate interior angles theorem. Okay, then what else do we have? We have this piece of given information. BC is congruent to AD. That is given. And then lastly, we have that reflexive property of congruence. BD is congruent to BD by the reflexive property of congruence. So there we have it. We have our side, angle, side, side, angle, side, and side, angle, side. So we can say that these two triangles are indeed congruent. Triangle ABD is congruent to triangle CDB because they are sassy, side, angle, side. All right, perfect. Let's go ahead and look at our next example here. Check it out, example 4. Okay, so we have this picture here. what is given is that QP, that's ray, right? Ray QP bisects angle RQS. So this ray bisects angle RQS, which is this angle right here. So we need to think about that. What does that mean? Why are they telling us that? What does that ray bisecting this angle, what does that mean? The second piece they give us is that QR is congruent to QS. And we have to prove RQP, this triangle, is congruent to SQP, this triangle here. I wonder how we're going to do this. Do you have any ideas? Okay, let's take this first piece. All right, so what does that mean? What does it mean for QP to bisect RQS? Well, if it's bisecting, it's cutting this angle in half, and if it's in half, that means they're equal. So we know that this angle is congruent to this angle right here. Okay, so we have those angles are congruent. I'm going to put one arc mark there to show that. Then what does this say? It says that, okay, we have the tick mark here. QR is congruent to QS. Okay, so we have a side and we have an angle. Do you see anything else for this triangle and this triangle? Do you guys see that reflexive property of congruence there? QP in this triangle is the same as QP in this triangle. They're the same. So we have our side angle side and our side angle side. So therefore we can show that those two triangles are congruent. Perfect. Let's go ahead and write our proof. So the first part we're going to write is right here. Q ray, I'm going to make a ray, QP bisects angle RQS, and that is because it's given. Now, because of that, remember it splits it in two, right? In half. That splits this angle in half. So this is the same as this. So we're going to say angle RQP is congruent to angle SQP. Why? What is the reason? And the reason is because of a definition of a bisector. That's what it says in the definition. If a bisector bisects an angle, it cuts that angle in half, which means those two remaining parts are congruent to each other. Okay, perfect. Now let's add this piece. Line segment QR is congruent to line segment QS. That is just given information. And then what's that last bit right there? QP is congruent to QP because of the reflexive property of congruence. And then lastly, we just write what we proved here. Triangle RQP is congruent to triangle SQP because it's sassy. Side angle side, side angle side, side angle side. Boom, that is it for example 4. We'll see you in the next lesson. All right, bye.